This is Ramnath Mani welcoming you to my YouTube channel on the evolution of industrial automation. In this episode, I am going to talk to Davy Demeyer, who graduated from Howest University, Belgium in 2004 and started working with Promatic and later Actemium, Belgium. He wanted to travel around the world and took assignments in Europe and then shifted to China in 2006 with its growing economy. Along with two colleagues, he commissioned 4 massive continuous annealing lines for cold rolling mill for Wuhan Steels, one of the largest steel companies in China and worldwide. Subsequently, his time was split between some major projects in Belgium and Germany and a few greenfield projects in China. Eventually, he specialized in supporting multinational pharmaceutical, chemical, and food companies in their expansions and investments in China, working closely with global engineering teams, often flying in from the US and Europe, and later supported their local teams once the greenfield projects were completed. Having been connected with industrial automation for 20 years and sensing that there has not been any change in process manufacturing workflows for over 20 years, and at the same time, there is an untapped opportunity to go one step further from the classical DevOps, he decided to start his own organization named Acceleer, based out of Brussels, working on design ops for process manufacturing. In this interaction with him, he has shared his experience in various industries across the world and his new venture, which would be of great benefit to the next generation of industrial automation engineers. Welcome to my YouTube channel, Davy. And how I would like to go about today is, take a little bit of your introduction. You have been connected to the automation industry, as I understand, for over about 25 years, maybe. And you have been mostly in the process industry, from what I can gauge. And I would like to get a bit of your background and, how you started with automation and why you chose to go into the, the process area, etc.
Okay. So hello, Ramnath. Thanks for inviting me. So I'm Davy. I'm from Belgium. I'm in the automation industry for 20 years. So I ended up in automation industry because I decided to study for it. So in Belgium at that time, you could choose a master in electromechanics and specialize in automation. And actually, how I chose it, before that, I was already programming. Remember on the first Intel 486 computers, I programmed in BASIC. And then I decided I wanted to do something with software, but I wanted to see things moving. So because of that, I thought, okay, it's more interesting to go to the automation direction, where you can go into the factories and make actual products instead of just going the classical software route. And then, I graduated in 2004, and then I joined a system integrator in Belgium. At that time, it was called Promatic. And over the years, this company got acquired by a big French system integrator called Actemium, part of the Vinci Group, which is now very, very big. So there's about 500 business units all over the world and about 20,000 people. And what I already did from quite early, I told my managers I wanted to go abroad. If you have a project for automation and it's somewhere outside of Belgium or even outside of Europe, please send me because I want to see the world. And that was very interesting because most people don't want to do this because they have the family, they cannot travel for long times. So I was quickly sent to first in Europe, to UK, to Germany. And then in 2006, the steel industry in China was really, really booming. And we had a customer who was building these big annealing furnaces. And they asked us to send a couple of people. And I was one of these engineers to go first to Wuhan. So you remember Wuhan from the COVID. So Wuhan is a very big city in China, and it has one of the biggest steel factories. So I went there and I stayed there around 1 year almost to commission 4 of these big annealing lines. And then after that, China kept growing very quickly. So I went back to commissioning a couple of chemical plants. And then finally in 2012, because of another acquisition that we did, I ended up moving to Shanghai to help incorporate a local business that well, it was not a local, it was still part of an international company, but it was a business that did design build. So, design from the PNIDs in the process industry. They help design these PNIDs and then they build them. So they bought the equipment, they installed the tanks, they welded all the piping. So they were focusing on pharma, food, and chemicals. So, but they had no automation. They subcontracted all the automation, and at that time, so in 2012, the automation was very, very basic. So I ended up moving there to Shanghai to help integrate the team and to build a new team from scratch for the automation and for the industrial software. And that's what I've been doing for the last 10 years. So we supported our multinational customers in food and pharma and chemicals who came to China to build out their local manufacturing. And we supported them with automation and over time also more and more software like MES. And they fly in. So we had these customers flying in with the global engineering teams. They explained us what they wanted to do. They explained us what possible corporate standards they had, and we implemented the projects. So that's a bit my background. So I did this until start of this year. This year I moved back to Belgium because I started my own company, and it didn't really make sense to start this in China.
That's right. Absolutely, you're right. So, uh, how is it that I understand that you went into the steel industry to start with, and therefore that's how you got into the process industry as such? Can you share some of your experiences, both, I mean, challenges that you faced and the success that you faced in those industries?
Actually, I always did process industry, even when I started in Belgium. So I still first did some projects in Belgium. I started in pharmaceutical industry. That was very tough at the start, because remember, I had a software background, and then in pharmaceutical automation, the biggest work we had to do was making the documentation. We had to make the documentation and then the validation scripting and things like this. So actually, I did this for a very short amount of time, and then I quickly moved away because I wanted to be more hands-on, spend more time in the factory, spend more time with the software. I then went to food industry, to dairy industry, so milk plants. That was very interesting. And then over time, I did indeed the steel industry and the chemical industry. Um, it's all been very, very interesting, very challenging projects, very rewarding to see after doing these projects from the start till the end, to finally see the plants up and running, producing the product. But it's also quite tough. These projects tend to be messy. You have requirements. You need to figure out a way to put these requirements in a design, to program them. The requirements change, or they're not entirely correct. And then we also work with a kind of software that's typical in our industry. So we work with dedicated software packages that are dedicated for the hardware. So we don't really have a lot of tools to our disposal except the tools that the vendors give us to manage our projects. So even though we do automation, we have to do a lot of effort, a lot of manual effort in order to keep our development under control. So I've had a lot of positive experiences, but I've also over the years become quite frustrated about how we do this kind of projects.
Have you faced any of the challenges that generally, I mean, people, when they try to put in IT into the manufacturing, they find the resistance coming from the OT side where people are used to a completely different set of norms and different way of working. Have you faced any challenge during this, convergence of OT and IT?
Oh yeah, for sure, for sure. But I also understand this, and I also think it's normal because we do work in the plants. We have a special environment. The environment has special requirements. It has limitations. It is normal. You cannot just say, okay, we're just gonna implement IT practices. We cannot just implement normal software. So we have these automation systems. We have to pay attention to safety. We have moving machines. We have moving plants. So it's normal. Although it's often goes a little bit too far. So we are also quite how to say this in industry we are a bit less progressive. We're more conservative. Sometimes we are too conservative. So for sure, I've seen this many, many times. I've seen a lot of opportunities where it should not have been like this. Um, but I also understand it. So what I generally um, try to recommend is we need to take into account the limitations we have. We need to take into account the environment we have, but still we should think about how can we make our own life easier and how can we make what we do more scalable, because what we do today is not very scalable. So I understand it, but I do want to bring some change to how we do things.
It's very nice. You have worked also in the Asia, you worked in China, etc. You also worked a bit in Europe. Now, do you see any change in the terms of philosophy, in the terms of, the way they look at manufacturing and the introduction of IT into manufacturing and how they implement it? Do you see any difference or, it's been
Yeah, it's a very big difference. So I know how we do it in Europe quite well. I also know how people approach it in like USA or Canada, because a lot of our customers who flew into China, they were teams from the US or Canada. In Asia, I've only seen China. I've mainly seen China. So the difference is very, very big. When I first went to China, there was almost no automation. At that time, so that was 2006. At that time, the only industries that started to automate were the steel industry, the oil and gas, the car manufacturing. And everything else, if they could do it without automation, they did it without automation. And then from 2012 on, still in 2012, it was very limited. Companies only wanted to have the very basic automation. And then we went to a change around the time. So Germany came with Industry 4.0, and China came with the answer called Made in China 2025, I think. It was called like this. So basically, then the message was okay. It was mainly aimed at robotics. So China said, okay, we need to start automating more, bring more robotics to our manufacturing. But in general, they also brought the idea that people should have more automation and software in manufacturing. And after that time, we saw okay a pickup in the speed of automating. People were really much more interested, although at the start it was mainly about showing it. So what we quickly saw after that, people made a lot of dashboards. So they like to make these big dashboards and to show what was happening in the production without actually thinking what is now the value from it. So they like to have this at the entrance of the factory. So when they did the factory tour, they could show, okay, we have a digitized factory. But it went less deep to the core of the value. Where in Europe, you see when people make something, they will first think about the value and the return on investment. Another big thing that's not only about software, that's in general. In China, everything is much more people focused, people based. So if you do some kind of engineering, it's much more in the heads of the people. People much more work together by talking to each other and then relying on the other person that will happen. While in Europe, and I'm pretty sure in the US it's also like this, we more want to first document things. We discuss something, but then we document it in engineering documents, and then the engineering documents become the source of truth. And in China, that's much, much less the case. And in some areas, almost no documentation exists. Like in software, in automation, you would typically walk into a plant, and most of the plants, they barely have any documentation about how the software works. And that is still the case today. So this is one of the biggest differences that we have.
Yeah, I can realize that. I mean, India is also quite similar to China in that aspect. And I've seen, of course, in the US and in Europe, I mean, where they are much more consistent. They have a full view of what they want to do, and then they start doing things. So, of course, that definitely it's a big difference.
Yeah, so you also notice this in the project progress. So in Europe, people would say for automation projects, you design everything, you prepare all the software, and then you do a FAT, factory acceptance test, before you go to the factory. And during the factory acceptance test, people want to see the entire software run, or at least 90%. And in China, we see exactly the opposite. So people would just prepare the basic automation that you just can communicate with the devices maybe. And then they would send a team to the site. And then on the site, they have a very long development and commissioning. And people talk to the commissioning team about how they want to have it work. And they would actually even avoid to write it down, because the moment you write something down, you lock the whole project into a target. So they would prefer to keep things open. And then they think, okay, during the commissioning, we can be much more flexible and we can much easier change. So it's a very, very, very big difference.
And what are your views on, the connectivity, security, and, the convergence itself, which you talked about? And the fact that, how much of, let's say, information that comes in and, gets displayed, how much of it is used? What are your views on this?
Well, the IT OT convergence, and this goes along with the Industry 4.0 mindset. My opinion is that this has not been enough based on software. So I see what mostly happens is people try to, they say, okay, we need to have data exchange between the automation layer and the higher layers like the ERP. And then they somehow try to make this communication. But what has not really happened is bring the way of software thinking to the automation layer. So, and you can also see this in a lot of documents, a lot of the early Industry 4.0 documents, although they were not all like this. But in many of the recommendations, you see almost no talk about software development or modern software development or how to manage software. It is a lot about communication, how to standardize the communication. And I think this is a big bottleneck for the automation world, because we want to reach scalability. We want to automate more. We want to be able to do more projects, do them faster. If we have multiple plants inside the same company, we want to be able to roll out standards in an easier way. And you cannot just realize this by saying, okay, we're going to standardize or IT, OT communication protocols or data structures. You also need to find a way to scale your automation layer. And your automation layer is always your bottleneck. So what people typically realize, they make a pilot plant, a pilot project in one of the plants where they optimize the automation, they optimize the higher levels, the ERP, the MES, they make everything work together. And then there is so much focus of the top management, of the experts in the company, of the suppliers, there's enough budget, they can make it work. But then they need to roll it out to the other plants. And then we typically see that maybe the higher level applications can be scaled, like SAP can be scaled. The MES can maybe be scaled if it's set up in the right way. But then every time this automation layer, because it's and every plant is different, it's maybe a different vendor, different hardware, different programming environment, different programming standard. So every time people get stuck on scaling out or mapping to the automation layer. And one of the big bottlenecks we have why we cannot do this is because it's totally not software based. We always have to go into these specialized engineering environments of the different vendors. We cannot really automate our own work. People sometimes have libraries, but these libraries, they are manually copied. We don't have package managers. We don't have Git. We don't have proper repositories. And so I think that's my opinion that until now it's a bit a missed chance, and there has not been enough focus on this aspect of the IT OT integration.
Well, what is your opinion on the new buzzwords like digital twin, unified namespace? What are your opinion on these?
Yeah, so unified namespace, the basic idea is not so new. So we have been putting things in the same namespace. So what is the meaning of the namespace part? That's this S95 ID, or S95 is the recommended way to do it. So you try to put your equipment inside a certain structure that matches the structure of your organization and your equipment. This has been done for a very long time. So in OSIsoft Pi, people do it like this. There was a startup in Germany called Inmation, and that was a couple of years ago. They were acquired by AspenTech, so they also really started from this namespace ID. So the namespace ID is just the proper way of doing things. What's a bit new in UNS is the recommendation to do it with open architectures like MQTT, for example. This is something that's really interesting because, of course, if you have to depend on OSIsoft Pi to build your data infrastructure around it, that's going to be very limiting. That's only maybe 5% or less of the companies who can use something. So it democratizes a lot the way of connecting data. The problem with the UNS is that it is being presented as something that can solve everything, and that's totally not the case. Like we had one of the last projects I did when I was still in China, we had to make a design for the MES that could incorporate with the UNS. And we spent 5% of the time just defining how the UNS would work, because it's basically quite simple. You just make your namespace, you define how it would look like. You have a broker. But then 95% of the effort goes to your MES. But your MES is mostly outside of your UNS. You could say, okay, we couple, we read data, we write data. So, and then the MES is just one example. You still have all your automation, you have all your other things. So, and then you also have your historical data, which is a known issue with UNS based just around the MQTT broker. So you also have your historians. So it's a good idea. It doesn't cover everything, but I like that there's things like this being more popularized. Then your other question of digital twins. It has been a buzzword, but I think it's an important concept because and there's different ways of looking what is now a digital twin. Do you just look at the 3D model? For me, it's important that you are able to have a digital representation of a lot of things in the plants. And we actually already have this. We make our designs, we make our PNID drawings, In many plants, we go to 3D models. Actually, if you have a model of something, you should be able to leverage this model, not only in the engineering, but also during production. And so for me, where we are probably going to go in the future with digital twins is we're going to create these twins as a model to make our engineering more efficient and to make our operations more efficient. I don't really believe in a digital twin where you start from the opposite direction, where you say, okay, you have a factory, now let's build a digital twin based on this, because this is too much manual work. Yeah, that's my view on the digital twins.
Very good. Now I think I'll come more to your own venture because I think you started a new one, Acceleer, if I am remembering right.
Correct.
I would like you to tell us what prompted you to start something of your own. What prompted you to do what you are doing? That is, what it does, and how is it going to be any different than any other product or any other solution that's available in the industry, and what are the benefits coming out of it?
Yeah. The reason I started it, there's a couple of reasons. First of all, I think I already mentioned that over the years I got a bit frustrated about how we have to do our automation projects. So I remember at the start I did it by myself, but when I was based in Shanghai, I built a team of engineers, and even by managing them, I noticed we always keep having the same problems. So, and the typical problems that we have, it's automation, it's very manual. Despite that we call ourselves automation engineers, we do a lot of manual work. Because it's so manual, we have a lot of mistakes that we introduce in our software. We know that these mistakes are there because we did everything by hand. So because of that, we then have to have very intensive testing stages in our development workflows. We don't have ways to automatically test them. Some people might say, yeah, some companies do it. And that's true. That's more in discrete industry that people start doing automated tests. But like if you do a pharmaceutical project in the processing part, it's basically a programming stage and then months and months and months of manual testing, which is mind blowing that we still do it this way today. It's we don't have the scalability like I mentioned before. So that's another frustration, especially having been based in China, having seen these multinationals trying to scale their standards. You almost have no tools to do this. So all of this, it's issues we have. And then if we look at the software world, we see in the software world where year after year they produce more and more software. It's like exponentially more every year. And what have they done? They have built a whole bunch of tools and workflows to make their own life more easy. So they basically have automated a lot of their own work. So they can start working at higher and higher abstraction levels. And we don't have this in the automation. We're basically just flatlined. There's basically no change in the last 15, 20 years in how we do automation. So that's one of the reasons why I wanted to do something about it. Of course, also having been living in China for more than 10 years, the Chinese are really, really very entrepreneurial in mindset. So I've seen a lot of my Chinese friends starting in companies and everybody starting their own company. So it makes you think. So this combined, I thought, okay, I have to do something about this. I cannot just keep complaining. I need to try to change something about this because we cannot continue like this. So that's the main reason why I started it. So what is it exactly? I call it so in the software world we have seen if the whole set of tools and workflows. People call this a bit in general DevOps. And what I want to do is I want to bring similar advantages to the automation world, However, we cannot just use the same tools. Like we already discussed before, you cannot just bring IT tools to industry. You have to take into account the constraints, special requirements, and also automation engineers. I don't think automation engineers will quickly change how they do the automation workflows. So we have a very graphical way of liking to do automation. We like to have a graphical view, code programming. So the automation engineers still like to work in this way. So I want to bring the same advantages from DevOps to the automation world, but while keeping a similar kind of workflow. So don't throw everything that we have out of the door. At the same time, when we look at the process industry, we can start earlier than what we do in software development. In software development, what do we do? People start programming some code. They have an iterative way of working to try to, so they show the code to the users, and then they improve it. In process industry, we don't work like this. We get the PNIDs from the mechanical engineers, and then we first have to make a design for our software. So instead of calling it DevOps, I propose we call it, in process industry, we call it design ops, because we want to have a workflow starting from the design. And so what I'm doing with Acceleer, it's a platform where people, instead of designing like today in Excel and Word, we move this design to a collaborative environment in the cloud. It still has the same look and feel, so it's a lot of like spreadsheet tables. You can make flow charts. You can describe things, but in human language. It's not a programming environment. And then based on this design, we will generate a big part of the code. So a lot of people have been doing code generation, often based on Excel and then scripting based on Excel. But we want to bring a more standardized approach to this. And so it is being done today. And if you think about it, a big part of what ends up in your software code, it's already described in the design. So it makes no sense to let automation engineers program it by hand. And then as a bigger vision, so I also believe that as the industry, we're moving more and more, or we will move more and more towards open ecosystem instead of one automation vendor supplying the entire vertical stack. And that's also what I want to implement with Acceleer. So I don't want to try to do everything. So I want to integrate with upstream engineering, like these PNIDs that we need to get our information from. So I want to integrate with automatic data extraction. And then also downstream, we don't only talk about automation, we also talk about the SCADA systems, we talk about MES systems, the UNS, data analytics, and even in the future, people want to bring the chatbots into production. So I want to have an open approach where people can use the platform to integrate other things in a more seamless engineering workflow. So that's the idea.
Okay. So who would be your customers, to start with?
Yeah. So again, the focus is on process industry. So typically food, pharma, chemicals. And there's two kinds of customers for Acceleer. The first one is the end users, and the second one is their system integrators. And you cannot really separate this because these two types of customers, they work together on projects. And I know this very well because I come from a system integrator. So an end user, a manufacturer, they want to define something, and at a certain level, they will go to a system integrator to implement the projects. So both are my customers. However, they have different advantages. Like an end user, a manufacturer will be very interested in now being really able to capture the functionality that's in the automation software. Because today it's very difficult for the plants, the factories, and the global engineering teams to know what is now exactly in the functionality of my plant? What is in the software? And it's very critical because that's almost one of the most important things you have in a factory, the automation knowledge. And of course, for them also the scalability will be more interesting. So if they implement this, they could, instead of the automation layer being a bottleneck, it could be a foundation for them to build their other digitization initiatives on top of it. Now, for the system integrators, what's more interesting for them is the standardization. It becomes faster to do the projects, and they can keep better control over the projects. So for them, it's a different value proposition.
Very good. So, I mean, from what I can gauge, I mean, yours is going to complement the existing system already existing and make it much easier for them to, I mean, execute and, implement. Um, so, do you also work with other platforms like Ignition or, any of these MES platforms that are there? I mean, would they all very seamlessly integrate with what you're doing?
We did a couple of tests with Ignition, but more for Ignition it's a platform, so you can do multiple things from it. Originally, it's a HMI SCADA platform. So the first test we did is also automatically generating all the tag lists and also auto-generating like a text for the operator to display. So imagine you make a design, you need to, for example, dose something in a vessel, and then what typically happens, it's a flow. Step 1, step 2, step 3. So step 1 might be open your valves, step 2 might be start the pump. And so if in your design you describe these steps, so it's a human language, you say actually what's happening, and then you bring this into the PLC and the controller and the automation. And the controller, this would become an integer. It would be really step 1, step 2, step 3. But at the HMI, at Ignition level, you don't want to see the number. You want to again see the text from the design. So what we've already been doing is to automatically extract these texts in a table format. So at the HMI or the SCADA level, you can look at the tag in the PLC representing the number and then properly showing the status of the machine or of the plant. And in the past, this was a lot of manual work to always configure these text lists. So that's an example of how having the model, having the design, it can bring benefit not only to the automation but also to a system like Ignition.
Right. What about the use of artificial intelligence? How much of artificial intelligence has been integrated in your system? Because,
Yeah,
today,
so we
that's a big
use,
buzzword.
yeah, I understand very well what the status is of artificial intelligence. Like we use, for example, Cursor to develop the platform itself. And Cursor, for people who don't know it, it's IDE, a software development environment based. But it's implementing an LLM, so you can basically chat the whole time with the AI, and it can help you do things. It brings a lot of power when you're a developer, and if you already know what you're doing. So imagine you want to implement a certain method. You could just make a description of what would happen, and you could say to the AI, okay, please now do this. And it just makes things faster. Before, developers, they would go to Google, they would go to Stack Overflow. What's happening today, developers, they don't have to leave their engineering environment anymore. They just keep chatting with the LLM. The LLM give them suggestions. So this is where we are today. So what I think about AI, first of all, you see that the different automation vendors try to make the same kind of ID inside their engineering environments. So Siemens is doing it, Rockwell is doing it. I think everybody is trying to do this. I'm a bit concerned with this approach because what we see in the software world again is that these LLMs, they are system independent. So you can use Cursor for .NET development, for JavaScript, for Python, for no matter what. It doesn't really care what you're developing. And again, in the automation world, we're again going in this direction where we think, okay, we're gonna have these siloed platforms where each team by itself will try to make a LLM that works best on their platform, or will make an engineering environment that only works for their platform. And the software world is different. The different offers on the market now, they compete with each other, but they all try to cover everything. So I'm a bit concerned that we're just getting started and we're already behind because of the way that we approach it. People are also saying that in the future, we will not have to care anymore because in the future, AI will program our automation. But that at least in the near future, it will not work like this. You cannot rely on the AIs. So like my example of Cursor and the workflow that I described, yes, you chat with the AI, it saves you a lot of time, but you still have to check what it's doing because sometimes it makes really stupid mistakes. Sometimes it can be small, but it makes a lot of mistakes. You cannot do this for automation. Yes, you could do it in the same way. You could say to the chatbot, okay, please make now a method. But you cannot tell your chatbot now, please take this design document and make my automation program. And then don't care about it anymore. It doesn't work like this. And then more importantly, when you have to make changes, then it becomes very critical because you are in a running plant, you know that your software has been validated, and then you need to make a change. It becomes even more difficult to use AI. So what I think we should first, well, we need to do it at the same time, but what is important to focus on as in our ecosystem is focus on the engineering tools because the AIs use the engineering tools. We need to make sure that the engineering tools are more open, that we don't have to keep working in these siloed environments. That would allow, for example, in the future, an idea like Cursor to also be able to work in the automation world. And then secondly, and that's more what I'm trying to do with Acceleer. So Acceleer, I mentioned it does code generation, but the code generation is not based on AI. So the code generation is fully deterministic. You know, if you have this design, you are 100% sure that the generated code will look like this. In contrast to AI that generates code where you don't really know what will happen. However, where I see a future, it's where the AI will manipulate the design. So imagine that you make a change in your plant. Imagine you just add a couple of valves on your PNID, and then you ask the AI, now please add these valves. Then the AI will first update them in the design, and then it will be much more easy to see what the AI is changing. You open your valve list and you see, okay, yes, my new valves are there. Or you open your procedure and you can see, oh, I see that in the design that here this valve is indeed being added. In contrast to having to check the code, which is very difficult for most people. Process engineers, they will never understand what happens in the code. So I see AI much more powerful on top of tools that make the automation engineering more powerful, instead of expecting that AI will directly, totally, blindly replace our entire workflows.
As I understand, I mean, I was attending one of the recent seminars where, people were discussing about AI, especially in industrial automation. And what the consensus was that, probably the coding, etc., can all be done by AI, but still the domain knowledge, which is absolutely important in any industry in terms of flow, in terms of, process of manufacturing, that still cannot be captured by AI, and that has to come from us. And and the other things like coding, etc., based on that can all maybe happen by AI. But still, the domain knowledge is going to be a very, very important factor, which still, going to rest with us to do. So
yeah, but there's actually surprising a lot of domain knowledge already inside the LLMs. If you try to reason about the process, about PNIDs, and people are doing this. you see that it knows a lot. Where it's missing is really proprietary process knowledge. So that will be interesting to see how we will handle this. Because I can see a future where actually the workflow based on AIs, not just one AI, but a workflow that has been engineered to use a lot of AI, could be able to design a plant in a minimal amount of time. At different stages in the engineering process, we still approach the engineering process like we would do today. We first make the process flow diagrams, we go to the P&IDs, then we go to the equipment lists, we go to the automation description, we go to the programming, the commissioning, and there's different parallel steps. Like for the electrical part, you need to make the electrical diagrams. I think we will still have this, we will go to a situation where we set up automated workflows, and at every step, we replace a big part of our manual work by the LLMs. For example, making this P&IDs, and people are experimenting with this. We let LLM doing this without the LLM having to already worry about the downstream automation part. And then you come to this limitation of the LLM not knowing certain things. And why does it not know certain things? It will know specific process knowledge that's owned by the manufacturers. And then what might happen is that the manufacturers, they might go to their own proprietary LLMs that come into the process. So you would have a lot of general LLMs, but you might have at certain moments proprietary LLMs from either the end manufacturers or from engineering companies. So you might have engineering companies specialized in certain things, like you already have this today. So you have engineering companies specialized in for example, biofuel extraction, and so they could bring in their knowledge with a specialized LLM. But in general, I think we will go to engineering workflows that will be super fast in the future, because a lot of this manual work will be just compressed because the LLMs do a lot of work, and we will have to come in as humans to check and correct certain parts of the engineering workflow. And then I suspect over time that our intervention will just become lower and lower and lower.
How does, I mean, whatever you're doing, under which category in the IS standards does it fall? And, how do you define your product in that area?
How do you mean?
The international standard, IS standard, I mean, 95 or, whatever.
Well, it's not really an existing kind of product. So it's not a control system, it's not a MES, it's not a historian, it's not a SCADA system. It's for a big part an engineering tool that flows between these things. So we also in the past, because of these closed silos, we didn't really see the engineering tools being separated from what has actually been built. So it's a bit a new concept. I'm not the only one. There's other people trying to build this, but in general, in the industry, it's a new approach, and that's again what I say. I think in the future we will go more and more to an ecosystem, and then the engineering, because so you also see this with open process automation. So open process automation is the idea where we're going to split up the DCS. The hardware will become the DCNs. And then on top of the DCNs, you will have the different DCSs running, but as a software. And then even at the software level, different things might be split up, and at the hardware level also. So one of the biggest concerns with open process automation is because you will not have a single company being responsible to ensure that everything is okay. And so the only way to make this work is to have much stronger engineering tools that are independent of the different building blocks. And so that's what I mean by we're going to move towards a more ecosystem approach, where you have different products and different engineering tools that are specialized to bring all these products together. And Acceleer fits more. It's not only focused on open process automation. It also fits for the current systems. But Acceleer is more like a system, an engineering tool that helps make everything much more easy and help to tie everything together.
Very good. Are you already working with some customer or no? Still in the process?
Well, we launched officially 3 months ago, and so we are testing with a couple of teams, both end users and system integrators, on the platform. So at this moment, we're collecting a lot of feedback. We already got quite some feedback where we thought, oh yes, why did we do like this? So we have to change the approach because people are used to work in a certain way. Of course, I know a lot of the workflows, and because I've been doing this for 20 years, but people still come with surprising things that we didn't think about. So if people are interested to try and to give a lot of feedback, then I'm very interested to talk to them.
Very nice. How do you think that in terms of the future, the role of automation and especially now that you're doing in Acceleer, whatever you're doing, and new things that are coming, artificial intelligence, etc. How do you see the technology moving in the industrial automation area?
You mean at the automation layer itself, or in general?
In general, I
everything
would
that's in the
say
machine?
I would say in terms of control systems for automation industry. More
Well, the control
process
systems.
probably because you're more in the process industry.
Yeah, but I also see the evolution in discrete industry, because in discrete industry we see a very interesting evolution where people go to the next generation of engineering software. So Siemens has Semantic AX, Beckhoff, I forgot how they call it. Beckhoff has something, BNR has something, and Codesys is preparing Go. And what is common about all these engineering environments, they are much more like our classical software engineering environments. Some of them are even based on Visual Studio Code. Some of them take a fork and build on it. And what's important is they change the way of thinking about engineering. So instead of building everything around the engineering environment, they do how it should be. They build the engineering environment around the code. So and that's how it's being done in software, in the software world. So in the software world, everything is files. So you have the code files, you have the configuration files. So it's plain code, it's JSON files, it's XML files, and that's what this new generation of engineering environments is doing. It doesn't mean that we will totally switch to totally text-based programming. So people will still be able to program in ladder. They will still add the SFC capability or a CFC capability, but we will have much easier access to the underlying configuration files. And this opens up a lot of things. So we can use proper version control. We can put it in Git systems. We can use it in more powerful DevOps environments. So you can take the code, you can automatically build it, deploy it to a test environment, and deploy it to a staging environment. So we can much faster spin up environments to do quick tests. Of course, deploying to the production will still be classical. People will still have to sit next to the machine, sit into the plant and give their final permission. But it becomes much more powerful. So that's what we see in the discrete automation. We also see that people are much more starting to program something. They let automated tests test everything, which gives a lot of confidence. So then afterwards, every time they make a change, they just have to run the whole test cycle again. and they are confident that it still works. Like this is very important in pharma. We have to go there in pharma, because now in pharma, people are very, very afraid to make changes. They have to prove, they have to think about how do we ensure that the validation is correct? How do we ensure that everything is still working without having to spend months and months of manual testing? So this is where we're moving to. And then in the process industry, I already mentioned it's open process automation. There's no other way. Vendors are not talking too much about it for now. I understand they have their current DCS systems, but that's the only way that we can make also process industry faster, because the vendors promote to put the DCS also in these pharmaceutical plants, like Emerson Delta V. It's one of the most popular systems in a biopharma plant. But how do we build these plants faster? How do we change them faster? We have to find a better solution. So the only way is to go to a more open system that we can build engineering tools around it to much faster develop the automation also. So that's what I think for the future.
Thank you very much, Davy. It's been a great pleasure talking to you. And I wish all the best for Acceleer. And I'm sure you're going to bring in something very new to the industry. And it'll be, I would say, a win-win for both for you and the industry. And I am hoping that it'll come out very fast, and you'll have great success. Thank you very much. And
okay, thank you.
The best. It's been a great pleasure talking to you. Thank you.